Hello everyone, and welcome to Rational Expressions and Equations lesson number 4. My landlords are vacuuming. Hopefully that's not too loud for you. I can hear it a bit. I'm wondering if the mic is picking it up, but I guess we'll find out. So today we are looking at adding and subtracting still. This is part 2 of that lesson, but we are going to be looking at denominators with factors in common. The one thing that we need to look at that's new is that it's important to factor the denominators in the expression, if it's possible, before beginning to add or subtract. And I'll show you what I mean by that. So let's go jump right into an example here. I'm going to start with example B. So we have 4 divided by 5x plus 5 plus 3 divided by 2x plus 2. So before we even start adding or subtracting, I'm going to factor these. So the bottom, oh no, my pen's being ultra sensitive. Oh, no. Okay. Gotta figure out what's going on. Give me 1 second. There we go. 4. So I can factor a 5 out of this binomial on the bottom. So it looks like 5x plus 1. And then in the second one, I can factor a 2 out of that binomial. So now I have 2x plus 1. Oh, good. So now you can see that they have a common binomial. The problem now is that we just need to match the coefficients. So we can multiply both terms by 5 on this side and by 2 on this side. And what we get is 4 times 2 in the top is 8. And then we get 10x plus 1 plus 3 times 5 is 15. And we get 10x plus 1. So we can rewrite that if we would like as 8 plus 15 all over 10x plus 1. And then 8 plus 15 is 23 over 10x plus 1. And that is as simplified as we can go. It is important that we say that x cannot equal negative 1. That's our non-permissible value. So if we hadn't factored out that 5 and that 2, we wouldn't have realized that the common denominator was pretty close to being the same. We just had to multiply something really small. And we saved ourselves a lot of complication. So in the next one we have 1 over x squared minus 1 over, so I'm going to factor an x out of this binomial right here. So now I have x, and then we have x plus 2. So you can see now that in order to get a common denominator, all I have to do is multiply this side by x plus 2, top and bottom. And on the other side, I just have to multiply by x. So yeah, the first term, I'm going to have x plus 2 in the top. And that pen bleed, I'm sorry about that. I'm not sure what's going on. And in the bottom, we have x squared multiplied by x plus 2. And then we subtract, now we have x in the top of that one over, well, this x times this x is x squared, x plus 2. So now we can rewrite this as an entire fraction over x squared multiplied by x plus 2. And now I have x plus 2 minus x. So now x minus x cancel, and we are left with 2 over x squared x plus 2. And that's as simple as that goes. Do our non-permissible values. X cannot be 0. or negative 2. Okay, so we are going to look at some larger denominators here. We have 5 divided by x plus 1 times x minus 2 plus 2 divided by x plus 4 times x minus 2. So you can see we actually have a factor in common in the denominator. So what we're looking to do is write this as one big fraction over a common denominator. So you can see that if I multiply on this side, x plus 1 over x plus 1. I apologize, my pen is bleeding a little bit and it's making it a little bit messy. And then if I multiply on this side, an x plus 4 over x plus 4, then my denominators are going to be the same. I will have x plus 4, x plus 1, and x minus 2, and then x plus 4, x minus 2, x plus 1. So now my denominator becomes x plus 4, come on. X plus 1 and x minus 2. That's my denominator for both terms. So the first numerator is 5 multiplied by x plus 4 plus 2 multiplied by x plus 1. So I can simplify that. That 5 multiplies into both of those terms, and that 2 multiplies into both of those. And now I have 5x plus 20 plus 2x plus 2 all over x plus 4, x plus 1, x minus 2. I think I fixed the pen, which is good. And now we can combine all of our like terms. So the top is 5x plus 2x, which is 7x. And 20 plus 2 is 22. And we leave the bottom alone because if we don't, then we're going to have to refactor. Uh-oh. So that's as simple as we go, but we still need to do our non-permissible values. Come on, pen. X can't equal negative 4, negative 1, or positive 2. There we go. Let's go on to the next page. Hopefully that made sense. I feel like that pen bleed is really throwing me off here. So in that last question, sorry, I'm just going to scroll back. Our denominator was factored, so it was good to go. But we should always factor it before we start adding or subtracting. So in this case, we can actually factor the p squared minus 1. That's a difference of perfect squares. So we can write that as 4. And then we're going to split that into, oh man, I need to buy a new pen. P squared is p times p, and 1 is 1 times 1. 1's a plus, 1's a minus. So when you do that, you see that we have one binomial in common. They both have a p plus 1. So the only thing I have to do to get a common denominator is multiply this side by p minus 1. And so now I can rewrite that whole equation over that common denominator, p plus 1, p minus 1. And now I have 4 plus 2 multiplied by p minus 1. And we can simplify that. We're going to multiply that 2 through. 4 plus 2p minus 2 all over p plus 1, p minus 1. And then what does that come out to be? We have positive 4 and minus 2 in the top. So I can reduce that top to 2p plus 2 and p plus 1, p minus 1. And then you can actually factor the 2 out of that, out of the top there. So we have 2 p plus 1 all over p plus 1, p minus 1. And we can cancel, but before we cancel, we need to define our non-permissible values. So we say p cannot equal plus or minus 1, and then we can cancel that out so that we get 2 over p minus 1, where p cannot be plus or minus 1. So we haven't seen a lot of this step right here, where we do the adding and we still have to reduce. We did that reduction in lesson 1 and 2, but in lesson 3 we didn't see much of that. You're going to start seeing it again, where you're going to have to add these two terms together, or these two expressions together, find your non-permissible values, and then still go through that simplification process. Now we're getting into trinomial denominators. I know everyone's very excited to make these even harder, so let's jump right in. We have a trinomial in one of the denominators, you can see, and so it's going to be important to factor that before we do anything else. So the first term stays the same, 2 over x plus 1 minus, and then on the top we have x minus 1. And so our bottom is a trinomial with no constant in front of it, so we can factor by inspection. So we're looking for two numbers that multiply to negative 3. Multiply to negative 3, add to negative 2. So that'll be minus 3 plus 1. And you can see now that we have a binomial in common in the denominator. They both have an x plus 1. So in order to make this a common denominator, I just have to multiply this side by x minus 3, top and bottom. So when I do that, I can write this whole thing over the common denominator of x minus 3, x plus 1. And now in the first term, I have 2 multiplied by x minus 3 minus x minus 1. And remember that there's that imaginary 1 here that's going to factor into that binomial and change the terms, or the signs of the terms. So don't forget about that. So now I can factor this 2 into both terms in the brackets. So I have 2x minus 6 minus x plus 1 all over x minus 3, x plus 1. I can combine my like terms. 2x minus x is x. Negative 6 plus 1 is negative 5 all over x plus 1, x minus 3. So I didn't have to define my non-permissible values until now, because I haven't done any eliminating. Like I haven't reduced anything from the top and the bottom, or canceled anything from the top and the bottom, and I'm not going to be able to. This is as simple as it goes. But now we still have to say that x cannot equal negative 1 or 3. And that's your final answer. All right, let's do this one. A little bit bigger, but not too bad. We have both denominators as trinomials, so we can rewrite that. No. Haha. Oh my gosh, same mistake. I think I'd learn. There we go. So now we just want to rewrite both of those denominators in factored form. So they're both trinomials with no constant in front of their y squared term. So I'm looking for two numbers that multiply to positive 2 and add to negative 3 for the first one. So I can rewrite that as factors y and y. So two numbers that multiply to 2 and add to negative 3 are going to be minus 2, minus 1. And then the second one, we're looking for two numbers that multiply to -2, but add to +1. So you're going to get y plus 2, y minus 1. And you can see here that we have a common binomial in the y minus 1. But the first one has y minus 2, the second one has y plus 2. So now we're going to have to multiply the first one by, I want that in green, there we go, y plus 2, top and bottom. And the second one we're going to multiply by y minus 2 in top and bottom to get common denominators. So what you are left with is 3 factors on the bottom: y minus 2, y minus 1, y plus 2. And on the top you have y plus 2. It's multiplied by 1, but you don't have to change that. Anything multiplied by 1 is just itself. And 3 multiplied by y minus 2. We'll simplify the top. So we have y plus 2 plus, that 3 multiplies through, so 3y minus 6 all over y minus 2, y minus 1, y plus 2. And now we have y plus 3y is 4y. And plus 2 minus 6 is -4. Y minus 2, y minus 1, y plus 2. So you can probably see that you can factor a 4 out of that top binomial. So we have right now 4y minus 4, but if we factor a 4 out, we are going to get y minus 1. So I'm just going to rewrite that. I'm running out of space. 4y minus 1. And you can see that there is a cancellation, but before we do that, we want to state our non-permissible values. Y cannot equal 1 or plus or minus 2. And now I can reduce that so that we get 4 over y minus 2, y plus 2. And that's our final answer right there. Awesome. I'm going to do one more example. It's a pretty big one. It's a ton of factoring, but that's okay. So you see here we have a trinomial divided by a trinomial minus a trinomial divided by a trinomial. So we actually want to factor all 4 of those trinomials. I know, crazy, right? So let's do this one at a time. So we're going to factor the first one into 2 terms. We're going to factor the bottom one into 2 terms. We're going to get a subtraction, and we're going to factor the second one into 2 terms and the second denominator into 2 terms. So the first one is x squared minus 3x plus 2. So we're looking for 2 numbers that multiply to 2, positive 2, and add to -3, which will be x minus 1 and x minus 2. And then in the bottom, we have 2 numbers that multiply to positive 4 and add to -5. So the same idea here, x minus 1, x minus 4. And now let's look at the next one. X squared plus 10x plus 24. 2 numbers that multiply to 24 and add to positive 10 is going to be x plus 6, x plus 4. And the last one, 2 numbers that multiply to 12 and add to 8, both positive, are going to be x plus 6, x plus 2. Fantastic. Most of you probably realize by now that in the first term, we can cancel out a factor, and in the second term, we can also cancel out a factor. Before we cancel out any factors, what do we need to do? That's right, we need to define our non-permissible values. So x cannot equal 1 or 4 or -2 or -6. It has to have all 4 of those because all 4 of them are in the denominator at the beginning. Now what we can do is x minus 1 over x minus 1 cancels. X plus 6 over x plus 6 cancels. And we can rewrite our equation as x minus 2 over x minus 4 minus x plus 4 over x plus 2. So now we know that in order to make a common denominator, I need to multiply both sides by x plus, or top and bottom by x plus 2 on this side, and top and bottom by x minus 4 on this side. And what we get is x plus 2, x minus 4 on the bottom, and then we get x plus 2, x minus 2 on the top, minus x plus 4, x minus 4 as the second term. So hopefully we're going to leave the bottom. Hopefully you all recognize that these two factors right here are the result of difference of perfect squares binomial. So we can say that that is going to be, let's see if I have enough room here. I could scroll a little bit further, I guess. X squared minus 4 minus, and then this one here, x times x is x squared, and 4 times 4 is 16, all over x plus 2, x minus 4. Okay. So now we have, well, this -1 out here, so it's going to multiply into both of those. And we're going to get x squared minus 4 minus x squared plus 16 all over x, oh, not squared, plus 2, x minus 4. So now you can see that x squared minus x squared cancel. -4 plus 16 is 12 over x plus 2, x minus 4. And that's as far as we can go. So there's the simplified version of our rational expression and our non-permissible values. And we are done. That was a long one. Good job. Thanks for sticking with me. That's it for the weekend. Only 4 more lessons to go. Thanks for watching. Don't forget to like and subscribe.